Hey, Course 3. Today we're continuing to work with algebra equations, talking about solving for maybe the variable that isn't already by itself or isolated. For example, usually when we solve for circumference, we're solving for, right, the circumference, the distance around. In theory, they could say, well, this is the circumference. Like they could tell you circumference is 500 inches or something, and we know pi, but what was the diameter? If we know that, if we know this and we know pi, what is diameter? They could make you solve for that part. And you're probably thinking, well, then I would do, 500 equals pi diameter, and then I'd have to solve for the missing factor. When we're missing a factor, we divide the product with the known factor, and that's how we would get that, right? It would be 500 divided by 3.14. In theory, if we wanted to solve for d, instead of isolating it through the algebra, we could isolate it before doing any calculations. Let me explain. We could just isolate the d by dividing pi right away and say, well, diameter is always going to be circumference divided by pi. And the value of that is, now when we input values, it's a little simpler, it's a little quicker, right? We can just quick go 500 divided by pi is d. But it's also nice because anytime we solve for diameters, we're ready to go with this formula, right? It's like when we solve distance, rate, time problems, we usually think of solving for distance, but why shouldn't we think of it sometimes in terms of rate? Rate, technically, would be distance divided by time in all cases, and that's valuable to remember because if a problem ever asks for rate, we can just go straight to the distance divided by time part instead of acting like we need to plug in the distance here, plug in the time here, and then solve for rate. Maybe it's quicker just to quick do the division right away. So we're rearranging before we input values. We're isolating the variable we want to solve for before we put what they are worth. We could do it with this problem right here. The illustration shows that W stands for the complete length of the entire segment, made up by two smaller segments, so we can show it as W is x plus b. If they ask to solve for x, and we already know b and w, you could divide the product by the known factor, right? Or the book says, let's rearrange right away. Let's look at this problem and say, well, what will I end up doing? I need to divide, or I need to subtract. Should have showed division before. I need to subtract the b off, right? I need to take b off of both sides. I don't need to know what it's worth yet. Let's just write the problem. Let's move the equal sign over here. I like that better. Now we're done. We don't know what they're worth, but we've solved for x as far as we can. We've put x on the left by subtracting the b's. It's actually easier than having to deal with actual numbers, as long as you can understand what we're doing. What's this formula look like? That's the Pythagorean theorem that explains the relation between side lengths in a right triangle. And usually we think of, you know A and you know B, so we need to solve for C, right? But sometimes we've known C, haven't we? So it's like when we solve for B instead. Instead of putting in your value here and in here and then wondering this, what if we rearrange so the b is isolated before we put the values in, before we input values? Subtract a squared from both sides. And isn't it true that whenever you need to solve for b squared, or for b, it's always c squared minus a squared, because we subtracted a from both sides. Then if they ever told us that this is 5 and this is 4, sorry, we don't know b. If the a is 4, we could just go and put that in. 5, 4, right? 25 minus 16 is B. Hmm. 25 minus, okay, yeah. We gotta square root it, right? Then we're ready to go. So we're isolating before we start. Why don't you try A and B?